So hi friends, today I am showing you the my project multi LLM decision assignment. So for this assignment, I show you first the diagram how it's our architecture being gone. So basically, whenever user asks a query, I little bit zoom this. So whenever user asks a query, it using the Redis for the rate limiting the query and check out the memory check. So the similar kind of query is re-executed already and it's stored in on its Redis cache server. So it gives answer from this cache server. If the query is not stored in a cache server, they need to go through the request analyzer token count. It check the token count of the token, complexity of that user query, and it goes to the Redis system through worker pool. And in this worker pool, we can say that if there are multiple we are running this code as an asynchronous mode, so we have an open so many workers for doing a task. So one of worker is going to the router logic and check out which good better which is good LLM model to give the output response for this situation. For this, if the model query is simple, they need to go with the 8 billion parameter model. If the model query is complex, so it goes to the 70 billion parameter. For now, the router logic is hard coded. If the word is provided in so okay, so whenever the coding words like write a function or write a code or fix this code, this kind of words are available in the query, we can consider this query as a coding task. Whenever the word is analyze, compare, evaluate, then we can consider this 3 point query is a complex query, and we have to use better model in this case. For this, we use 70 billion parameters of model. If the query is simple and not considering this type of word in that query, then it considered as a simple query. So for now, we have these three four models available in this case. One is a llama 3.18 billion parameter, kimi k2 instruct, which is good for the coding, llama 3.370 billion parameter for the defining the answers or generating the explain the concepts, and 99b is our failback mechanism. So if one of these are not available, then it go with the Gma and give generate output for us. Okay, so let's try this. I restart the website. Here you can say the backend is connected. Here is a system prompt. Here is temperature value which we can show. First of all, let's check write a code to print hello world in Python. So you can see there is a moonshot kimi k2 instruct model which is used for generating this output. Total tokens are 37 tokens are used, and the cost of this request is around 10 to the 1 2 3 4 5 10 to the power 5 $9 would be used, which is pretty low. And if I say explain compare VLLM in detail, evaluate with the LLM. Okay, I fix. Okay, this is been the query. We can see the lava's 3.370 billion parameter is used in this case. So the latency for this request is 2577, and the cost is pretty high if you can consider with the Kimi-K2 instruct model. So you can see there is perplexity, score, blue score, rock score, clue score, and super clue score with the detailed explanation what these metrics about. And if I send a simple query like hi, it gives on 3.18 billion parameter instant model, which is a cached answer because before recording this video I run the high command, and it getting output from that cache value. So the cost you can see here is says 0. Let me run again with hello, which is not cached answer. So you can see I say an hello word, and it use the 580 milliseconds of the time, and the token count is 948. It 948 because of it's take an system prompt. It take as an consider this output tokens also for the getting the better answers. So total count we can use in this run. So hope this video feel understandable to you. Do you have any question? Let me know please. Thank you.